It's just an unbelievable feeling to be back here on planet Earth, back in our great country, and back with all my family and my friends. This mission is the latest achievement in our country's space program, but it's not the last. There will be more. It's in our DNA of our country to explore, and we must never stop doing this. We must lead, we must learn, and we must discover.
I'm going to be honest here. As a kid, I caught the outer space bug. I was a huge astronaut nerd. I remain so to this day, unabashedly, because these are the men and women who one day will be immortalized for their incredible courage and sacrifice when mankind reaches past this planet's boundaries and does indeed become citizens of the universe. Scott Kelly is one of those, back on Earth and back home after spending nearly a year on board the International Space Station. Watched, measured, checked, rechecked, rechecked, and will be for quite some time as scientists seek to understand if man can indeed stay in space long enough to reach Mars and then beyond. Strap into the capsule. Let's get to work. First up, he is the Vice President and Chief Scientist at the National Space Biomedical Research Institute and the Deputy Project Scientist for NASA's twin studies involving the Kelly brothers, Dr. Graham Scott. Joined by the Senior Space Editor at Ars Technica, armed with a degree in astronomy from the University of Texas and a degree in meteorology. Not bad. Eric Berger. Gentlemen, I want to thank you both for joining us. We got a long way to go. We're going to spend a little time here today on this because it's worth it. Dr. Scott, to you first. The thing that I saw this morning that just caught me, after a year in space, Scott Kelly returned 2 inches taller, which is something that no one would imagine. What do we know about the expected effects of space on his body that you're looking for?
Well, firstly, Ed, unfortunately for Scott, I think he would agree, he won't get to stay 2 inches taller. He will, over the next few weeks, he will reacclimate to the 1G environment, and he will lose that transient 2 inches that he gained. In terms of the body, this is one of the reasons we are executing this 1 year mission. Up until now, US astronauts have spent a maximum of 6 months in space. And so when we go to Mars, it'll be more or less 3 years, let's say, in terms of the transit there, time on the surface of Mars, and then getting back to Earth. So we need to start spending longer and longer periods of time in space to find out what's going on. In terms of the eyes, you may have heard, Ed, that some of the astronauts are experiencing some visual impairment, some in general mild changes with their eyesight. So this is one of the things we want to look at in a 1 year mission versus a 6 month mission. We also want to see how the astronauts are doing when they're exposed to 20 times the radiation field here on Earth. So on the International Space Station, they're getting about 20 times the dose of radiation. So these are some of the questions, and we're also looking at the omics, at the molecular level, and it's a beautiful experiment where we can compare Scott to Mark because, of course, they're identical twins, and so we've got an ideal control for looking at the molecular level of what's going on in the microgravity environment.
Eric, in the years that you have covered space travel, NASA, and issues such as this, just take this one experiment, these 340 some odd days here, and give us a sense of how important the people at NASA, the scientists themselves, believe this is in going forward.
I think there's a sense that this is really an important piece of research. It's one step toward Mars. It's an important step. There are many more to go. But I think there's a feeling that, finally being able to answer some of these long-duration spaceflight questions are an important first step toward getting to Mars.
The interesting thing that, and again, the doctor said it here, and I just wanted your comment on this first, Eric, and then, Doctor, I'm going to come back to you. The radiation factor is something that's not talked about. These astronauts are constantly being bombarded by radiation, and we still haven't figured out, have we, how to basically keep the astronauts safe on a long trip, have we, Eric?
No, we really haven't. And while there is more radiation in the near space environment of the International Space Station, it's not nearly the level that you get when you move beyond the Earth's protective radiation belt. And so, if you get to the moon or between the moon and Mars, you're exposed to all sorts of much more harmful radiation from the form of cosmic rays and things like that. And so while this study, almost a year in space, begins to address those questions, it really doesn't get at the radiation question, which is a much harsher environment in deep space. And as for protecting astronauts from that, no, we really don't have a good, cost-effective, economical way to do that on a 6-month journey in deep space.
Dr. Scott, I got about 90 seconds left. We'll take a break, come back and talk some more. But is it fair to say that at this point, we're really still just kind of shooting in the dark here a little bit when it comes to this long term. I mean, it's great. You now have a controlled experiment here with his twin brother, which you couldn't have done anywhere else. But we're still finding out so many things that we didn't know about what can happen to the human body in space, even after all these years being there.
Well, we know a lot. Let me say there have been a lot of approximately 6-month missions. And so we know a lot about how the body works over that time period. What we now need to start doing, Ed, is doing a number of these one-year missions. And NASA has started to think about that, about additional one-year missions. Because as I mentioned earlier, when you go to Mars, you're going to be approximately 3 years in space. So we need to build up the length of time, the length of experience that humans have in space. Now, I will mention that the Russians have had now 5 crew members that have spent over a year in space. So they're pretty experienced with this. This is the first U.S. crew member, and I think we're going to see more U.S. crew members spending a year in space. And then it's possible that the length of time may even go beyond that, because again, you've got to eventually get to 3 years. Now, a good chunk of that time will be on the surface of Mars, but it's still going to be important to look at how a crew of 4 or 6 individuals operate, within that team environment for that period of time, where basically imagine you're shut in a room, and you really can't leave. There's no additional people coming or going, and so these are the sort of studies that we're going to see more of, these one-year missions, I think, Ian.
Doctor, hang on one sec, because you just used the word Russians in there, which we're going to take a break and come back and discuss, because that's something that sticks in my craw as basically just one of these space nerds. Dr. Graham, Scott, Eric Berger, stay buckled in. We're going to take a pause, come back, and then talk more about Mars and the reality of space travel right here on The Hardline. In light of everything that's happening in our political world at the moment, how necessary we close out the week with something a lot more optimistic, but at the same time, wrapped in politics and what happens inside the Beltway in D.C. Welcome back the senior space editor at Ars Technica, Eric Berger, and the vice president and chief scientist at the National Space Biomedical Research Institute, Dr. Graham Scott. All right, Eric, I'm going to begin with you on this one, because the doctor said the word there, Russia, which still actually sits in my craw and so many others. Here we are with these marvelous experiments here. We still don't have a lifting body of our own to get to the ISS. We still don't have a space program anymore, a manned space program. And people are going, there's 2 parts to this question. Why are we not spending the money, first of all, to be there? And then why do we have to spend the money?
So the question of why aren't we spending the money to get our own people into space, we're trying to correct that with the commercial crew program that's paying Boeing and SpaceX to develop rockets and spacecraft to take crew into orbit. The reason why we had to do that, why we've had this 6 or 7 year gap in spaceflight capability, or will have since the shuttle retired in 2011, is because space policy in this country really hasn't been a priority. It was in the 1960s. It was part of the Cold War and the space race, and we put a lot of resources and attention on the space program. Since then, it's kind of faded into the background.
Eric, but a part of that, are we still paying the price for the Columbia disaster?
I think that's part of it, because that was kind of the impetus that led to the retirement of the space shuttle. But a bigger part of it is you have this real disagreement between the White House and Congress on where we should be going with our space policy, and so you kind of get this fractured approach, which leads to big gaps.
Dr. Scott, when it comes to that space policy, it still comes down to money, because it's still, I think I remember from The Right Stuff and the novel, Bucks means Buck Rogers or something like that. You still need to have the money. We're doing all these research, we're doing all this, and yet we're still looking at a time when we hear we're going to be on Mars in 2000, in 2010, in 2020, in 2030, in 2040. I mean, do you yourself and the people that you deal with, you work with, get exasperated every day waiting for this to happen? Because it's going to take another couple of lifetimes, it seems.
Well, let me answer it this way. I was born in '64, so I did see Neil Armstrong walk on the moon, and I thought that we would be in the vicinity of Mars by now. I'm now 52, so time has marched along. But I do believe that NASA has a really good plan for getting to Mars in the next 20 or so years, building up to that, going out into what we call cislunar space, going out into the vicinity of the moon, getting experience with, as Eric mentioned, operating in this more onerous radiation environment. I think that funds are needed to really lower the risk to really study this radiation question, for example, also to better understand the visual impairment question. So it's important to build the rockets and it's important to do the engineering, but I think it's also really important to, probably the weak link here is the human. And so we need to better understand these risks if we're going to have, 4 or 6 crew members, let's say, in space for 3 years. So a lot of work needs to go on between now and, let's say, 2035 via a series of missions which will increasingly put humans further away from Earth, again, back in the vicinity of the moon and then potentially out in the vicinity of an asteroid. So I'm looking forward to that. I think NASA does have a good plan, and I hope we can do that.
Eric, 20 seconds to you. Do you think we'll be on Mars by 2035?
No, I'm 42 and I'm resigning myself that we're probably not going to see humans on Mars in my lifetime. NASA talks a lot about its journey to Mars, but it doesn't have the funding and really the approach to get there. I think that there needs to be an honest reassessment of space policy.
We need to go because it is part of our legacy. We have to get off this planet. It is part of what we are. We are explorers. I only have a few seconds left. Dr. Scott, to you, 20 seconds. Have you talked to Scott?
Not yet. He just got back here to Houston today, and he's undergoing a series of medical tests and, starting to get reacclimated to Earth. So I have not yet, but I anticipate I will be speaking with him fairly soon.
A shower and a cheeseburger, you would guess, might be top of his list?
I think so, and he's mentioned that a few months from now he might be taking a vacation in Tahiti. So I don't know exactly what his plans are, but I hope he gets.
I hope he does. He's going to get a chance. Now he gets the sun and the wind and the ocean. It's going to be wonderful to have him back. Dr. Graham, Scott, Eric Berger, gentlemen, thank you so much for this. We will speak again. It's a fascinating topic. The space nerd in me will always have you guys back. Thanks so much. Rock on, true believers. Enjoy yourself. Have a great weekend. See you Monday back here on The Hard Line.